arbitrary function in R4. So this is the function to define a hypersurface in R4, and this number is also sort of the volume, but not exactly the volume. It's a hypervolume of some hypersolid in R4. Okay, so this is still talking about assigned volume, but you have to put the volume in R4 instead of R3. Okay, you have to put it in R4. Again, this is not exactly the key points in the triple integral, but I want you to understand this is indeed some physical meaning for that. Okay, so we still got a couple minutes. I want to give you the idea of what simple region is. So the Z simple region is actually bounded by two functions of so this will be the simple region in Z variable. Basically, this solid is bounded between two functions, still upper function and lower function. Now these two functions are going to be two functions involving x or y. Okay, so this solid, as the integrating solid, is built upon a region in xy plane. And then I have a lower function as a surface defined by h1 of xy upon this region, and an upper function defined by h2 of xy. And the solid is between these two surfaces. Okay? So this is z is equal to h1 xy. This is z is equal to h2 of xy. So basically, this solid is built upon a region in xy plane. And then I have a lower function of h1 as a surface involving xy. I have an upper surface involving h2 of xy. So this solid is bounded between two surfaces, lower surface and upper surface. Okay? So this is what it means for Z simple region. So for Z simple region, I have to rewrite this integral R, and then from h1 of xy to h2 of xy, f xyz, dz, and dA. If it is a Z simple region, and then I immediately know the interior region is interior integral is integral with respect to Z. Now think of where I can pair of x and y. So if I go outside and look at this region R as the region I build upon my integrating solid, and then need to identify what this region is in xy plane. Am I right? That with me? I need to identify what this region in xy plane. If it is a y simple region, then I'll be able to write it as a to b from g1 of x to g2 of x, and from h1 of xy, h2 of xy, f xyz, dz, dy, and dx. So first, this is a z simple. Second, this is a y simple. Second, it is a y simple. So you have to pair off your integrating region, integrating solid, step by step. First, you have to identify it is a Z simple region. Then you need to look at this solid project back to the xy plane as a region in xy plane. So you have a solid, then a region in xy plane. This region on xy plane, you have to use your double integral skills to identify what it is. If it is a y simple region, then dy in the middle, dx in the outside. If it is an x simple region, dx in the middle, dy in the outside. You can even use polar to identify your region on xy plane as well. And you can also identify your region in xy plane by polar coordinate system as well. So that's why I said in triple integrals, we have to use our skills in double integrals all the time. You have to pair this step by step. You have to throw away z, and then about x or y, what kind of region it is. Okay? If it is a z simple region, you write down these two functions immediately. And then going outside, you have to use double integral to identify what this projection back on the XY plane is. Okay, so we will practice on Wednesday's class a lot. So spend time